Let's assume there are currently 1,000 cases of a viral flu present in a total susceptible population of 4,000 people in a region. And let's say that lately the cases have been documented to be increasing by 20% each day. Can you create a logistic model for the number of cases of the flu? So, we'll want to start with the general form of a logistic function, L over 1 plus AE to the negative KT. This time we're not given the growth rate or the A value. We have to find them all. So from what's given, we can let L, the upper limit, be the 4,000 people that have the potential of being infected. And we should let the initial number that are infected be 1,000. Now we want to find A and K to make our model complete. So A is not too tough to find. All we have to do is plug in the initial value of Y and then plug in a time of 0. As you can see, that is going to make this part go away. And we're going to get back to a formula that we had used in the past here, which is L over 1 plus A. That is the way you find the initial population value. But we want to do the reverse here. We want to find A by knowing the initial population value. So we'll plug in that 1,000, set it equal to 4,000 over 1 plus A. And we'll just want to solve that equation to reveal that A is 3. Alright, now we have several things that we can use in our mathematical model. We got L and A, but we still have to find K. And that's where this next formula comes into play. It is a formula for the logistic growth rate, and K is the logistic growth rate. So it involves a new letter that we hadn't used before, little p. Little p stands for the initial percent growth at time 0. So ours is 20%, according to the statistics that have been done. And we can put that into decimal form. Okay. And now we're ready to use it to calculate the logistic growth rate. The formula says it's P times 1 plus A over A. So our percent growth at the start is 0.2. We'll do 1 plus 3 over 3 because our A is 3. Okay, and I get 0.267 approximately. Okay, now we're ready to build the entire model. So it'll be y as a function of t is equal to 4,000 over 1 plus 3 e. You have to get the negative in there. 0.267 t. And it's done.